In the last video, we explored solving for equations. And as we discovered, an equation is kind of like if you had a scale and it's balancing on the equal sign. You have to have the same thing on each side of the equal sign for it to be true. So 2 plus 5 could be on one side, but then you'd have to have something that equals that on the other, like 7. Okay, now equivalent equations, it's a similar concept, and this is when you have two different equations. So let's say x plus 4 equals 10 could be one equation, and another equation could be x plus 6 equals 12. Now, if these two equations are to be equivalent, that means that they're going to need the same solution set, or the same value for x has to result in a true statement. So in this case, for the first equation, what would make this true? What value for x would make this true? Well, if x equals 6, then it would become 6 plus 4, which is 10. So for x equals 6, it would be 6 plus 4 equals 10. And that would be true. Okay, if I wanted to check to see if the second equation was equivalent, I would plug in 6 for x in the second one to see if that's true. So let's rewrite that one for x equals 6, and you would get 6 plus 6 equals 12. And that is true. So these two equations are in fact equivalent equations. And you can test that with any other 2 or 3 equations. It could be a number of equations if you want to see if they're equivalent. Now, an example of two equations that would not be equivalent, so they would be non-equivalent. An example of those would be x plus 8. X plus 8 equals 10. And then x plus 8 equals 14. Now the solution set for the first one, x would have to equal 2 for it to be true. And then the second one, x would have to equal 6. So you'll see that they don't have the same solution, therefore they're non-equivalent. You can't plug in the same value for x and have both of them end up being a true statement. Okay, let's do an example where we're going to test to see if two equations are equivalent. Let's say we have the equation x plus 2 equals 5, and then x plus 5 equals 8. Okay, are these equivalent? Are these equivalent? Well, let's see. What would make the first equation true? What value for x? What value for x? Well, x would have to be 3. 3 plus 2 would be 5. So x would have to be 3. Now, does a 3 work for the second one? Yeah, it does. If you plug in 3 for x in the second one, you would get 3 plus 5, which is 8. So it is. So your answer is yes. Yes, they are equivalent. Okay, so this is how you would check to see if they're equivalent. And I think that'll wrap up this lesson. So you kind of get an idea of how you'll go about solving equations. If you do something to one side of an equation, you can do the same thing to the other. And just to recap, another way to solve these, now these are pretty easy, but you'll get some where you can't see right away what x is going to equal. So if we were to take this first one, x plus 2 equals 5, and we wanted to solve for x. Well, like we said earlier, if you do something to one side of the equation, you can do the same exact thing to the other, and it's still going to be a valid equation. You aren't really changing anything. So if you do some stuff to one side, you have to do the same stuff to the other. Okay, so x plus 2. Now, if I want to solve for x, that means I want to get x equals something. So I want to get x by itself. So I want our answer to be x equals something. So the way I can do that is subtract 2. But now if I subtract 2 from this side of the equation, I need to do that to the other. So I need to subtract 2 from the other side of the equation. So on the left side, x plus 2 minus 2, well, the 2's are going to cancel out, and I'm left with an x. And then 5 minus 2 will be x equals 3. Okay, that's the first one. X is 3, which we already knew because we looked at it before. Now in a different color, I'm gonna solve our second equation, and that's x plus 5 equals 8. Now same idea here. I want to get x by itself. I want it to be x equals something. X equals something. And so I need to get x by itself. And the way I can do that, well, the left side is x plus 5. So if I take away 5, then this will cancel out. The 5's will cancel out, and you'll be left with x. But I need to do the same exact thing to the right side of the equation. So I have to take away 5 from 8. So on the left side, we have x plus 5 minus 5. Well, the 5's cancel out, and you're left with an x. And on the right side, you have 8 minus 5, which is going to give you 3. So we're getting the same answer for x, which, like we already knew, we knew these equations were equivalent, but this is just another way to solve that, is to get x by itself, to solve for x.